Give a single AI agent a big, messy job. Research a topic, write a report, and fact-check every claim. And watch it slowly lose the plot. Its context fills with everything at once. It's forgotten step 2 by the time it reaches step 9. So here's the 2026 idea. What if, instead of one overloaded generalist, you built a whole team? That's a multi-agent system. Several specialized agents, each a full AI on its own, working together toward a single goal, like a small company. A planner breaks down the work, specialists do the pieces, and a critic checks the result. It is genuinely powerful. But, and we will come back to this hard, more agents is not always better. Here's the whole team at a glance. At the top, an orchestrator that plans and delegates. In the middle, specialist workers, research, writing, code, each doing exactly one thing. And off to the side, a critic that reviews everything they produce. One goal, divided among many focused minds. Let's meet each role. Why one agent isn't enough? Recall how a single agent works. A model in a loop with tools and memory. It's brilliant for focused tasks. But pile on a sprawling, multi-part job, and two things break. First, context overload. The one window fills with the goal. The research, the draft, the tool outputs, all competing for attention until the model is drowning. And that context rot we covered last time creeps right in. Picture the lone agent's context window during that big report. The goal is in there. 50 search results, 3 draft sections, a dozen raw tool outputs, all of it crammed into one window, all of it fighting for attention, and the model, predictably, starts losing track. One desk, with far too much paper piled on it. Second, no separation of concerns. A single agent has to be researcher, writer, and critic all at once. And just like a person wearing every hat, it does none of them especially well. Worse, it can't critique its own work objectively. It's simply too close to it. And the fix is the one humans invented long ago. Divide the labor. The team. Roles. So you split that one agent into specialists, each with its own focused context, its own tools, and its own single job. The first role is the orchestrator, the planner, the manager. It takes the big goal, breaks it into tasks, and decides who does what, and in what order. It doesn't do the work itself, it coordinates it. Then come the workers, the specialists. A research agent that only searches and gathers. A writing agent that only drafts. A coding agent that only writes code. Each one's context stays small, clean, and laser-focused on its narrow job, which is exactly why each of them does it so well. And the role that quietly matters most, the critic or evaluator. A separate agent whose entire job is to review the other's output, fact-check the claims, catch the bugs, judge the quality. Because it didn't write the work, it can judge it with fresh, ruthless eyes. Maker and checker deliberately kept apart. Orchestration patterns. So how do you wire the team together? The most common pattern is the supervisor. A manager agent sits at the center. It delegates a subtask to a worker, gets the result back, decides the next move, and delegates again. The workers don't talk to each other. Everything routes through the boss. Simple, controllable, and easy to debug. The second pattern is the pipeline, an assembly line. The output of one agent flows straight into the next. Researcher, to writer, to editor, to fact-checker, each one adding its part and passing it along. It's perfect when the steps are fixed and sequential, with no manager needed in the middle at all. And the third is the most interesting. Debate or parallel. You spin up several agents to tackle the very same problem independently, each from a different angle. Then have them critique each other, or vote, and synthesize the best answer. It's slower and pricier, but for hard, open-ended problems, that diversity of thought genuinely beats a single chain. How they talk. For a team to work, the members have to communicate. And there are a couple of ways. The simplest is a shared scratchpad, a common memory that all the agents can read and write. Like a team whiteboard everyone gathers around. The orchestrator posts the plan. The workers post their results, and everyone stays in sync. The alternative is direct message passing. Agents send structured messages to one another, like emails or a chat thread, each one a clear request or result. And just as MCP standardized how an agent talks to its tools, new protocols, like Google's Agent-to-Agent, are standardizing how agents talk to each other. So teams built by different people can actually interoperate. Why? It's powerful. When it works, the payoff is real. Separation of concerns. Each agent's context stays small and focused, sidestepping the overload that sinks a lone generalist. And specialization, a tightly scoped agent, with just the right tools and instructions, simply outperforms a jack-of-all-trades on its own piece of the puzzle. And then there's parallelism. Independent subtasks can run at the very same time, across many agents, instead of one agent grinding through them one by one. Plus modularity. You can improve, swap out, or debug a single agent without ever touching the rest. Exactly like good software. A team scales in ways a single mind never could. When not to use it. But here's the hard truth most demos skip. And it's the most important part of this whole video. Multi-agent systems are expensive, fragile, and badly overused. Every agent is a full model with its own loop. So a team of 5 can mean 5 times, or more. The calls, the cost, and the latency of a single agent. You pay dearly for that org chart. And the errors compound viciously. We saw that a single agent's reliability already drops over many steps. Now chain multiple agents together, each one handing off to the next, and those failures multiply right across the pipeline. One agent quietly misunderstands the task, and it poisons everything downstream of it. More moving parts means more ways to break. So the rule, straight from the labs actually building these things, do not reach for a multi-agent system by default. If a single, well-designed agent can do the job, use it. If a plain, fixed workflow can do it, use that. It's cheaper and more reliable still. Add agents only when the task genuinely needs parallel, specialized work that one agent simply can't hold. Complexity is a cost, not a feature. So before you ever build a team, run this little checklist. Can one well-designed agent do it? Then use one. Can a fixed, predictable workflow do it? Then use that. Only when the task truly needs parallel, specialized work that won't fit inside one agent's head, should you reach for several. Start simple and add agents as a last resort, not a first instinct. The 2026 reality. That said, for the right problems, this is exactly where the frontier is heading. Deep research across dozens of sources. Large code bases touched by specialized agents. Complex workflows with a real division of labor. For those, multi-agent systems shine, and the tooling to build them is maturing fast. The future is teams of agents, used deliberately, not reflexively. And it's already here. Deep research tools that dispatch a small swarm of agents across the web and synthesize what they find. Coding systems where a planner, a coder, and a reviewer collaborate on a single change. The pattern genuinely works, precisely when the job is big enough to earn the overhead. So picture it like a company. One person can't research, right? And fact-check a giant report all alone. So you build a team, a manager to plan, specialists to execute, a reviewer to check, all communicating over a shared board. That's a multi-agent system. It is powerful. It is the frontier. And it is only worth the cost when the job is genuinely too big for one. So the next time one AI agent isn't enough, you'll know the move. And its price, hire a team, but only when the work truly demands it. The org chart is powerful. It just isn't free. Subscribe for more such intuitive videos